Okay, moving on to question 6. We're asked to find the acids and bases and label the conjugates, and we need to show the movement of electrons, and we need to figure out which side is favored at equilibrium. So quite a few things we got to figure out here. But first and foremost, we got to figure out what our acid is and what our base is. So if you're going through, remember a base, its job in life is to find a proton. So it is to find something that has a positive charge. So bases tend to have negative charges. Okay, so we look for whatever has a negative charge. That is usually going to be our base. It's a good place to start. If that's our base, then this better be our acid over here. Now with an acid, we better make sure that it has an acidic hydrogen, a hydrogen that's easy to get rid of. And typically we're looking for hydrogens bound to oxygens or hydrogens bound to our halogens or things like that, right? Those are our most common examples of acids that we have. Here we happen to have an example of a thiol, right? A hydrogen bound to a sulfur that is a fairly acidic hydrogen. Okay, so we have our acid, we have our base. Now we need to do some acid-base chemistry, right? It tells us to show the curved arrows for the movement of electrons. So we draw arrow from the minus, right, from the base to the acid, from the minus to the proton. We make a bond, we break a bond. Okay, so let's show what's going on. So the sulfur lost a proton, so it gained a negative charge, and my base gained a proton, so it now has a hydrogen there. And if we want to come back and color code this, right, there's our pink bond that we showed with our movement of electrons, and there could be a pink lone pair there from the arrow that we have going back to the sulfur. Acids turn into conjugate bases. And bases turn into conjugate acids. Okie dokie. Now we need to pick which side is favored at equilibrium, right? That's just a matter of finding which side has the weaker acid, right? Which side has the weaker acid. Or which side has the stronger acid and you pick the other one, right? So there's two ways to look at this, right? I prefer to find which side has the weaker acid. You can use pKa tables to look at that, right? You have the acid here, which is an alcohol or a thiol, right? So the choice of weaker acid is alcohol or a thiol. If you take a look at your pKa tables, it'll tell you that an alcohol's got a pKa of anywhere from about 16 to 17, and thiols are anywhere from 13 to 14, right? So you take a look at the pKa's, they can tell you this is a weaker acid, and so the favored side is going to be over here, right? At equilibrium, we're going to have more of our products, in this case the conjugate acid, conjugate base. All right, let's look over here. Take the same approach. We found our negative, there's our base. Found our acid over here. Okay, if that's the base, that's the acid. We bring in our, whoops, there we go. The base attacks the acid, sends in a lone pair. Draw our products. Our base turns into the conjugate acid, so it picks up a proton. And our acid turns into the conjugate base. And let's fill in some colors. There's the lone pair, right? There's the bond that gets made in between these. All right, so here's our options again. Base turns into conjugate acid. And this is our conjugate base. Okay, so again, we just need to finish up and say which side is favored at equilibrium. The weaker acid is the favored side. And I'll give you a quick hint here. This is known as a carboxylic acid. So these are fairly strong acids. In fact, it's got a pKa of about close to 5. Our acid over here, a protonated amine, I believe they're around 8 or 9, right? So we have our weaker acid over here. So this is going to be our favored side. So let's think about this for just a second. We said that we're looking for the weaker acid, which means that this is a stronger acid. So just think about the terms weak and strong for a minute. Why would equilibrium favor the weaker side? Well, if you're a strong acid, how are you going to behave? Well, if you're a strong acid, you're going to behave like an acid. And if you behave like an acid, right, that means you're going to do your job to give away a proton. So we could draw the reverse arrows here, right, to make our stronger acid act like an acid. So we could favor our equilibrium towards where we started over here. So think about strong versus weak. You can use pKa tables. You can look at stability of charges. Any of those ways are very good at predicting equilibrium.